India has done it again. The Indian Space Research Organization ISRO has achieved a groundbreaking milestone with its successful space docking experiment, or SpaDex. Today, we'll dive deep into the historic achievement that placed India among the elite nations in space technology. Let's explore the mission, its technical brilliance, and its global impact in details. So first of all, you have to understand about what is docking. What the fuck is docking, man? When it comes to rockets, one fact becomes abundantly clear: their capacity is profoundly limited. A significant portion of a rocket's structure is dedicated to fuel, leaving only minuscule fraction for a payload. Very bad. This consistent underscores why rockets are among the most complex and critical tools of a modern science. To accomplish large-scale missions, multiple launches are often required, making space exploration an incredible resource-intensive endeavors. But why is this technology so vital? Why do we need to launch a multiple rocket carrying substantial payload into orbit? The answer lies in humanity's ambitious vision of establishing a presence beyond Earth. Constructing habitats like the ISS International Space Station necessitates launching an array of modules and supplies over time. And second thing is human. Unlike many other species, humans cannot thrive in a harsh environment without artificial support systems. Space is an exceptionally hostile environment, and astronauts must rely on Earth-like conditions to survive and work efficiently. They require spaces for basic activities like eating, sleeping, exercising, and even conducting viral experiments. For instance, astronauts engage in research on food production in space, as future's long-term mission will depend on generating self-sustained resources. To create such livable conditions in space, we must construct expansive modules that can be joined together to form functional habitats. These modules must offer sufficient and technological experimentation. This need has driven the developments of a sophisticated docking and berthing technology that enable the assembly of such structure in orbit. Now let's explore two critical technologies enabling the construction of these space habitats: docking and berthing. These processes are essential smooth operation between spacecraft and stations like the ISS. So first of all, we have to understand about docking. Docking refers to the highly precise process where a spacecraft autonomously connects to a space station. For example, the Russian Soyuz spacecraft performs this operation by relying on advanced algorithms, precise fuel burn and thrust, and meticulous speed adjustments. Docking is an intricate procedure requiring an art of engineering and absolute precision. On the other hand, berthing. Berthing invokes a slightly different approach. SpaceX's Dragon spacecraft employs this method. Instead of relying solely on the spacecraft's algorithms, the ISS uses its robotic arm to capture this incoming spacecraft and guide it to its attachment point. This process alleviates the burden of extreme accuracy from the spacecraft and shifts it to the ISS advanced robotics. Once berthed, the modules can transfer people, supplies, and scientific equipments. You can understand by that. Consider a futuristic scenario. Humanity has colonized space and has been living off planet for centuries. Imagine needing to dock your personal spacecraft, your home and vehicle combined with the largest space station. Because parking isn't an option, these dockings and berthing technologies developed today will lay the groundwork for such future possibilities. We will owe immense gratitude to the pioneers who overcome these challenges to create the systems we rely on tomorrow. What seems like a technical feat today, connecting spacecraft with a pinpoint accuracy, will someday be as routine as pulling into a driveway. But the fundamental basic understanding about a docking and joining two satellites in space. SpaDex stands Space Docking Experiments. Is ISRO's ambitious missions to demonstrate in space docking technology. This involves two satellites named Target and Chaser. Target satellites served as a stationary module, while Chaser satellites perform the docking maneuvers. Why this important? Because in future we have to do lots of work like a satellite servicing for repairs and upgrades. India's planned space station by 2035, and of course interplanetary mission that requires advanced spacecraft assembled to orbit. With this, ISRO has joined the ranks of the United States, Russia and China, the only nations to have successfully demonstrated such a feat. The trusted PSLV C-63 rocket. Each satellite's weight is approximately 150 kg. Docking was achieved at an altitude of 500 km above Earth, making this is a huge milestone for ISRO. The satellite successfully undocked and redocked multiple times, proving the system's reliability. It requires precise navigation using advanced sensors and control algorithms. The spacecraft must account for relative velocities, orbital dynamics, and alignment angles. ISRO developed a unique autonomous docking system that performed these situations with near perfect accuracy. The SpaDex satellites were equipped with high precision cameras, LiDAR systems, and advanced AI algorithms to ensure a flawless operation. In orbit, the chaser satellites performed a series of precision maneuvers. Using onboard thrusters, the spacecraft had to align, approach, and finally dock with the target satellites at a speed of just a few centimeters per second. Precision that's truly remarkable. Another highlight was the demonstration of electric power transfer between the two spacecraft, a capability that is crucial for long-term mission. To truly appreciate this milestone, let's place it in the context. India's journey in space exploration has been nothing short of remarkable. In 2014, ISRO made history with Mangalyaan. It's a Mars orbit mission, becoming the first nation to reach Mars on its maiden attempt. And in 2023, the Chandrayaan-3 mission demonstrated Indian ability to land on the moon. Now with the SpaDex, India joins the US, Russia and China in mastering space docking technology. These nations have used docking for space station construction and interplanetary missions. SpaDex not only demonstrates India's capabilities but also positions it as a reliable partner for future international collaboration. This positions India as a serious player in the global space industry, with the global space market expected to reach $1 trillion by 2014. This achievement boosts India's credibility. SpaDex is a stepping stone towards India's human space flight program, Gaganyaan, and future upcoming missions. This competition in space technology spurs cost reduction, increased launch frequency, and innovation across industries. ISRO isn't stopping here. SpaDex is just part of a large roadmap. By 2035, ISRO plans to incorporate docking capabilities in satellite servicing missions. In the long term, these technologies could enable deep space exploration, such as a Mars mission or asteroid mining. In conclusion, SpaDex is more than just a technological milestone. It's a testament to India's growing prowess in space, a source of a national pride and a leap towards a future where India plays a leading role in the global space communities. What are your thoughts on this achievement? Drop a comment below. And don't forget to like, share and subscribe for more updates and cutting-edge space technologies. Thank you. Bye-bye.